Welcome back to the Institute. In this episode, we are basically going to solve about 3 questions that will contain problems from said, all right, radicals, okay? And we also go ahead to problem 2, where we'll look at domain and composite numbers, right? How to deal with composite numbers, and that'll be it for this episode. Okay, so let's go for question number 1. So with the question number 1, it says that we should express this expression in the form p plus q square root of 7, where p and q are real numbers. Okay, so this particular problem, we can look at it in 2 folds. We can use the difference of 2 squares to handle this problem, or we can use the rationalization, straightforward, right? So if you want to use the rationalization, I'm going to use the rationalization in here. But when I'm done, I'll show you the difference of 2 squares approach, so that if you're interested in that area, you can also use that method. Okay, so let's look at how we can use the rationalization. Okay, so we have 4 plus square root of 7 divided by 4 minus square root of 7 all squared minus 4 minus square root of 7 divided by 4 plus square root of 7 all squared, right? So this is what we have. Okay, now you know that if you have a radical over a radical, right, and you want to rationalize, then it means that you have to multiply both bottom and top by the denominator. You just have to change the sign, right? So this is what I mean. We are going to do this divided by 4 minus square root of 7 times 4 plus square root of 7 divided by 4 plus square root of 7. You multiply using the denominator, but now you change the sign in between the arguments, right? So that is what we have, minus, you do same here, 4 minus square root of 7 divided by 4 plus square root of 7 times 4 minus square root of 7 divided by 4 minus square root of 7 all squared, right? So we deal with this. Once we are done, we subtract. Okay, so we're going to have 4 plus square root of 7, then 4 plus square root of 7 divided by 4 minus square root of 7, 4 plus square root of 7, right, all squared, minus 4 minus square root of 7, 4 plus, 4 minus square root of 7 divided by 4 plus square root of 7, 4 minus square root of 7, right? So this is what we have. We just have to simplify this, then we subtract. Okay, so we go, this and this will give us 16, this and this will give us plus 4 square root of 7, this and this will give us plus 4 square root of 7, this and this will give us plus 7, divided by 16 plus 4 square root of 7 minus 4 square root of 7, then we have minus 7, right? So this is what we have on this side. We have to look at this as well. So minus we have 16 minus 4 square root of 7 minus 4 square root of 7. Then we have plus 7 divided by 16 minus 4 square root of 7 plus 4 square root of 7 minus 7, right? All squared. Okay, so let's try to deal with this, then we subtract. Okay, so we can see clearly that this and this will go, right? Because this is positive and this is negative. So they take care of each other. This is also positive, this is also negative. So they take care of each other. Okay, so now we can see that 16 plus 7, and that is 23, right? So we have 23 here plus 4 plus 4, that is 8. So we have 8 square root of 7, right? Divided by 16 minus 7, that is 9. So we have all over 9 minus 16 plus 7, that is 23. Then 4, they are all positive, negative, right? So that is going to be negative 8 square root of 7. Then we have, yeah, so that is negative 8 square root of 7 divided by 9, all squared, right? So we can see that this 23 plus 8 square root of 7 all over 9 all squared minus 23 minus 8 square root of 7 all over 9 all squared, right? So we have to simplify this, then we subtract. Okay, so 23 squared is basically 529. Okay, 23 squared, that is 529. So we have 529 plus 23 times 8 times 2, right? 23 times 8 times 2, that is 368. So 368 square root of 7, then plus 8 into 7 divided by 9, right? Minus, remember, it should be in the bracket because you are subtracting, and the negative will affect whatever is in the bracket there, right? So minus into brackets, 33 squared is 529. Then you expand the 2 with this, you're going to have plus, yeah, that would be negative 368 square root of 7, right? Yeah. Then the last one will give us minus, yeah, this will give us plus 16 into 2, right? Plus 16 into 2, plus 16 into 7, right? Divided by 81. Remember, 81. Okay, so we're going to have 529 plus 368 square root of 7, right? Plus 368 square root of 7 plus 8 times 7. Yeah. Yeah. So plus 16 times 7 Then we expand this, right? So we're going to have minus 2529 plus 368 square root of 7 minus 16 into bracket 7, right? All divided by 81. Remember, this is also over 81, right? So now, since they all have the same denominator, it means we can subtract the numerator, right? So we say that 529 minus 529 plus 368 square root of 7 plus 368 square root of 7 plus 16 into 7 minus 16 into 7 divided by 81, right? So we can see that this will take care of this, this will also take care of this. So we only have this and that, right? And 368 plus 368 is 729. 729. 736, right? So we have 736 square root of 7 divided by 81. Okay, so we can say that the value of P and Q is obtained as 736 divided by 736 square root of 7 divided by 81. So let's write it here boldly. So we can say that our P is equal to 0, right? Because we don't have any P, right? So we can say that our P is 0, our Q is 736 divided by 81. Then the square root of 7, right? Okay, so the value of P and Q is equal to 0 and 736 over 81 respectively. Now, we have another alternative to solve this, right? That is by letting A equals this term, then letting B equals this term. Then use difference of two squares, right? So that method is also this. We let A equals 4 plus square root of 7. We let B equals 4 minus square root of 7, right? So if A is equal to this, B is equal to that, then it means that we can say A over B all squared minus B over A all squared, right? So we use difference of two squares in this, right? So we have A squared over B squared minus B squared over A squared, right? So we can say that we have A to the 4 minus B to the 4 divided by AB all squared. So this, we can expand the numerator to have A to the 2 minus B squared, then A to the 2 plus B squared divided by AB all squared, right? So we can use this to actually evaluate this as well. Both methods are correct. Whichever path you choose will give you the correct answer. Okay, so that is it for question number 1. Now let's move on to question number 2. Give me some short break. I'll be back with question number 2. Okay, so welcome back from the short break. I believe that you have been able to go through the question number 1 and you're good with it. Now, let's look at question number 2. where we have been given two functions f and g, and they are defined on the set of real numbers by this rule. F is to x mapping onto square root of 16 minus s squared divided by s squared plus 4. And also j is to x mapping onto s squared minus 4 divided by 8 minus x squared, where x is not equal to 2 square root of 2. Right? Now we want to find the domain of f, the domain of this particular function f. Okay, so how do we get the domain of this particular function f? Before we can find the domain, we have to change the function from the rule form to an equation, right? So we say that let's f of x equals square root of 16 minus s squared divided by x squared plus 4. Divided by s squared plus 4, right? Everything is under the square root sign. Okay, so this is the problem. Now, how do we get the domain? You know, domain is basically the function, right, that will make the term that will make the function not to be undefined, right? So looking at this, we can say that first of all, the denominator, right? Look at the denominator. Remember, if you have s squared plus 4, it means that this right here can never be equal to 0, right? If this is equal to 0, the function will be complex, right? X will be complex, right? So we say that the denominator, the requirements of the denominator should not be equal to 0. The requirements of the denominator should not be equal to 0. Never equal to 0 because of this plus. If it had been negative, then we can say that it should be equal to 0. Okay, so now we know the requirement for the denominator. Let's look at the numerator. The numerator is s 16 minus s squared, right? So with this, we can say that it should be equal to 0, right? It should be equal to 0, right? So we can say that this is equal to 0, and so our x squared can be equal to what? 16. So we say that x is equal to plus or minus 4, right? So this clearly shows that s will contain positive and negative 4, right? So x will take positive and negative 4, that is inclusive, right? So the domain of f will be negative 4 and positive 4 inclusive, right? That is the domain of f. Remember, look at the condition they've given us. X is not equal to, comma, s is equal to 2 square root of 2. So it means that one of the terms will not be equal to 0, right? So, and that is what we've identified for the denominator, the requirement for the denominator. And the numerator, we had plus or minus 4. Now, let's look at the second part of the question. It says that we should find J ring f of x. J ring f of x. Now, this is where the composite function comes in. You know, if you have J ring f of s, that basically tells you that you want to find J ring f of s is basically telling you that you're going to substitute f, right, into g, right? You're going to substitute f, the function of f, into the function of g. So wherever you see x in the function of what? G, you substitute the function of x in there. Okay, so first of all, because we have square root of 16 minus x squared divided by x squared plus 4 for the f, then we have to find f of x all squared so that we can easily substitute into this, right? So we find f of x all squared, and that will be equal to 16 minus x squared divided by x squared plus 4 all squared, right? So this is what we have. This cancels this, and then we have 16 minus s squared divided by s squared plus 4, right? So that is what we have for f of x all squared, 16 minus s squared divided by s squared plus 4. So this is the function that we substitute into the g of x, right? So we're going to have g ring f of x to be equal to, wherever we see x, we substitute this, right? Wherever we see x squared, we substitute this, because we have already taken the square, right? So we don't need to square it here again. Because of this square, that is why I squared it here, to avoid the square root sign. Okay, so we're going to have 16 minus x squared divided by s squared plus 4, right? So this is what we have, right? This is what we have. Now, remember, there is a minus 4. So this minus 4 all divided by 8 minus the x again, and the x is this. So we have 16 minus x squared divided by x squared plus what? 4. This is what we have. So the work now is to simplify this. Okay. Okay, so we have j ring f of x to be equal to, because of this is over 1, right? So we'll have to find the LCM for that. And you know that the LCM for this, we can say that we have 16 minus x squared minus 4 into x squared plus what? 4, divided by x squared plus 4 divided by 8 into x squared plus 4 minus 16 plus x squared, right? Divided by x squared plus 4. Okay, so this is what we have. Now, we write it well to have 16 minus x squared minus 4x squared minus 16 divided by x squared plus 4 times x squared plus 4 divided by 8x squared plus 8 times 4. 8 times 4, right? That is 32. So we have 32 here. Then minus 16. Then plus x squared. Okay, so this is what we have, right? And this will basically take of this, okay? So that this as well will take up this, right? So we're going to have this, and this will give us minus 5x squared divided by this, and this will give us 9, right? So we have 9x squared. This and this will give us 16. 32 minus 16 is basically 16, right? So this here, we're going to say that our J of f of x, our J of f of x, J of f of x is equal to negative 5x squared divided by 9x squared minus 16, right? Okay, so this is clearly difference of two squares, the denominator, right? We know that 9s squared is equal to 3 squared s squared, right? And we know that 16 is equal to what? 4 squared. So we can rewrite the denominator as 3x minus 4 and 3x plus 4. Okay, so the denominator can be written as this, or we can leave it this way now. Okay, so this is the final answer for the B, the composite function. So remember, whenever you have a composite function, okay, if for instance you have J ring F of X, this basically tells you that you are substituting the function of F into the function of J, right? You are substituting the function of F into the function of J. And that is basically how we go by that. Very, very simple. And if you are substituting F into J, that means that whenever you see X in J, you substitute the whole of the function of F into that. That is very simple, right? So we will end episode 2 here, continue in episode 3 next time. All right. Thank you very much for watching. I really appreciate your time. Please don't forget to subscribe, share with your mates, and I'm going to give you more updates. Bye-bye.